Let's take a very simple quadratic equation. X squared minus 6x minus 7 equals 0. And we want to find out the solution or solutions for this equation. That is to say, the values for x which will make this a true statement, which will make x squared minus 6x minus 7 really equal 0. Now, we could simply factor this. It's such a basic equation. The only way we're going to get an x squared is if we multiply x by x, and look, 7 is a prime number. The only way we can get 7 is if we take a 7 and multiply it by 1. And we know that we want to have a negative 6, so the larger one is going to have to be negative, the smaller one positive. And if we FOIL this, we'll see that x times x gives us the x squared. The outside ones, x times negative 7 will give us a minus 7x plus 1x, that's minus 7x, plus 1x will give us a negative 6x. And lastly, the negative 1 minus 7 will give us a negative 7. So this is very easy to factor the old-fashioned way. Instead, we're going to factor it in a new and very complicated way. The reason we're going to bother doing this is that in order to learn a new technique, it's best to make the materials themselves very simple so we can put all our attention on the new technique. Now, what we're going to do here is, first, we're going to take the part which doesn't have a variable, the negative 7, and we're going to move it to the other side of the equation. So let's add a 7 to both sides. And now we've got x squared minus 6x. This is gone. The negative 7 and positive 7 cancel each other out, is equal to 7. And what we're going to do now is, this is so important, I'm going to write it out. We're going to take the linear coefficient. The linear coefficient is the negative 6. We call this a linear coefficient because, well, coefficient means works with. And this is the number which works with the variable which will give us a linear graph. If we were to graph just plain old x, it would look like this. It'd be a straight line. And because a single variable like this with a exponent of 1, first degree variable, graphs as a straight line, we call it a linear variable. And the coefficient that works with it is the linear coefficient. That's a very fancy word to be using, but once we learn to say linear coefficient, then I don't have to draw graphs to show you what I mean every time I want to let you know. Okay, we take the linear coefficient with its sign. In this case, that's a negative sign. And what we're going to do is have it, add it, and square it on both sides. So you'll take the linear coefficient with its sign, have it, add it, and square it on both sides. So here's the linear coefficient with its sign. That's a negative 6. We're going to have it divided by 2. Now, negative 6 over 2 gives us a negative 3. Then we're going to add it. So we're going to x squared minus 6x plus negative 3 is equal to 7 plus negative 3. And it's quite important that you put it in parentheses because we're going to be squaring it now. And putting it in parentheses makes it clear that when we square it, we're squaring the sign along with the number. The value of doing this is, now that we've set it up in this fashion, we can take the two squared parts of this side of the equation, the x, which was squared, and the minus 3, which was squared. Take them down, square that, and that's going to be equal to 7 plus negative 3 squared. Now, how do we know that x minus 3 squared is really equal to x squared minus 6x plus negative 3 squared? If we write out the x minus 3 squared, x minus 3 times x minus 3, write it out in full, and then we FOIL it, we'll get x times x is x squared. The outside ones, x and negative 3, will give us negative 3x. The inside, minus 3x. And the last ones will give us negative 3 squared. So we see we've got an x squared, a minus 3x and a minus 3x will give us a minus 6x, which is what we have here, and minus 3 squared is what we have here. So this procedure here gave us a precise equivalent of the full equation we had here. On the other side of the equation, we decided that x minus 3 squared was equal to 7 plus negative 3 squared, and that's going to be equal to 7 plus, well, negative 3 times negative 3 will give us a positive 9, and 7 plus 9 is 16. We changed the form of the equation, but we didn't change the meaning at all, because when we added a negative 3 squared to both sides, we did something entirely legitimate. This expression was equal to this expression, and when we add the same thing to both sides of a true equation, we change the form of the equation, but we don't change the meaning. So we took the linear coefficient, the negative 6, along with its sign, we halved it, we added it, we squared it on both sides, and we ended up with this new formulation of our equation. Now that we've reformulated our equation, let's go ahead and solve it. I wrote it out in this form so you could see that it really lined up with the original equation. But to solve it, let's move this back over to this side. Let's add 16 to both sides. And now we've got x minus 3 squared is equal to positive 16. So to find out what x is, we want to get x all by itself. So let's begin by getting rid of the squaring. Let's take the square root of both sides. And the square root of x minus 3 squared is going to be just x minus 3. And this is going to be equal to, well, the square root of 16 is going to be 4. But we're going to make that plus or minus 4, because x minus 3 squared is equal to 16 would be true if x minus 3 turned out to be a negative number, like negative 4. Negative 4 squared would be 16. And it would be true if it was a positive number. If it was positive 4 squared, it would give us a 16. So to account for all the possibilities for what the value of x could be, we're going to make this plus or minus 4. Now, since we're still interested in solving for x, let's add a 3 to both sides, plus 3, and now we get x, the plus and minus 3 cancel each other out. X is equal to either 3 plus 4 or 3 minus 4. So 3 plus 4 is equal to 7, and 3 minus 4 is equal to negative 1. So we know that the answers to x minus 3 squared minus 16 equals 0 are negative 1 and 7. And if you try putting them in, you'll see that's true. If we put in a negative 1 minus 3 is negative 4 squared. That would be negative 4 squared would be positive 16. Minus 16 is equal to 0. And 7 minus 3 would give us a 4. 4 squared is 16. Minus 16 is equal to 0. So these answers absolutely work. What this tells us is that if we were to graph this equation, y-axis, x-axis, when x is negative 1, the y value would be 0. It would have a y height of 0. It would rest right on the x-axis. And if we gave x a value of 7, the y height would then again be 0. So we've got now the two x-intercepts, which are the solutions to the equation. Let's see what other information we can get from this equation. What would be the value of the equation if we were right on the y-axis? If we were at the point where x is 0, because where x is 0, that's where x meets the y-axis. So let's write it out in function form so we can see that even more clearly. If f at x is equal to x minus 3 squared minus 16, if we set x equal to 0, then our equation would be worth this. We'd have 0 minus 3 squared minus 16, and 0 minus 3 is negative 3. Negative 3 squared is positive 9 minus 16, and 9 minus 16 is going to be negative 7. So we know when x equals 0, y is going to be equal to negative 7. 0, negative 7. So now we've got the y-intercept. We know the point on our graph where it intersects the y-axis. The last and perhaps the most interesting piece of information we get from writing the equation in the square completed form is this. We know where the vertex of the graph is. Well, first, we know that this is going to be a parabola because it's a variable squared. Now, if it was just a plain old x squared, we know it would look like this. And it would touch down on the x-axis. That is to say, it would have a y height of 0 where x is 0. So at the value x equals 0, you'd have 0 squared, so the output of this would be 0. Right there at the origin. If we made it x minus 3 squared, which is indeed what we have, then the y height, which would be the output of this equation, would appear where x was 3, because that would give us a 0 value when it was squared. So if x was positive 3, this is the point in the parabola where we touch down on the x-axis. So we know the touchdown point really should be over here at positive 3. But in addition to this, we have a minus 16, which means there is a vertical shift. So we're going to move our graph down 16 units. That means over here at, say, point 3 minus 16. That's when the graph is going to make its apex, where it's going to reach its low point or high point, in this case a low point. And if we were to connect these dots, we would find that we had a parabola which looked like this. Let's draw another one so you can see how this should look. Properly speaking, our graph should look more or less like this. So we'd have our x-intercepts at -1, 0, and 7, 0. We'd have our y-intercept at 0, -7, and the vertex of the graph would be at 3, -16.